is Shomulani. I'm a technical director for the data and search team in the Parliamentary Digital Service. And my colleagues and I are going to boast a bit about what we've done over the last 2 years, building a new open link data platform for Parliament. So what we do is support 2 existing data integration platforms for Parliament. One of them we call data.parliament, which is open link data in the W3C sense. Another one we call indexing and search, which is an internal tool colleagues in Parliament use as the basically major interface for interacting with parliamentary data, our own. And at the moment we're working on a new platform, a second iteration of what used to be data.parliament, using GraphDB, hosted in the cloud. As opposed to previous attempts, we've invested heavily in modeling. We are creating a data model of Parliament as best we can. We're taking that domain model and translating that into an ontology, which Chris will be talking about.
So we have a team that work with the experts in all the domains to write these very short, like mini ontologies, say just fact packet designs. And so in our team, we then take this work that they do that explains these relationships between these existing things in our system, and this is not how it normally goes. And so this is just basically what our ontology looks like in WebVal, which is a really good open source project for visualizing. So you get an idea of the sort of complexity of what we have so far, with each of these balls representing basically a class and all the edges being relationships between them. This is all, we just maintain all this manually just in a text document. Made a decision to basically make everything as easy to query as possible. So we use quite a lot of inference, more than Ontotext recommend we use, but we find that it does actually do a decent job of handling the amount of inferred statements that we end up with. So for classes, we use subclassing, probably makes bigger, maybe. Anyway, we use Jesus. We use subclassing for classes so that you can infer that something is part of many different groups. We use domains and ranges for all our object properties and sub-properties and stuff like that. And for data type properties, again, we also use a few restrictions where to make it inferable that something is part of some other group through a series of things we know about it. We end up having a lot of classes and subclasses and specific object properties to do that, and we realized that we could cut it down to quite simple restrictions that are quite good. So for example, this one tells us that if a form body has the form body type which has the label informally constituted, then therefore it is a informally constituted formal body, which is a weird name for anything.
One of many.
That's a quick guide to our ontology and the work we're doing on that. Anything else?
Yes, so I think it's interesting, some of what's guided our decisions on ontology design patterns is to use the classification available from these inferences as query tools. So our major consumer of data at the moment, we hope there will be many others, but at the moment it is the new beta.parliament.uk website that the team next to us are building. And the way we work with them is a team of web developers writing Sparkle queries against this model which the website consumes. So semantic publishing is basically what we're doing. using this model and I think 4 million asserted statements that we have at the moment, 12 million inferred ones. We recently exposed the public Sparkle endpoint against all advice. So it is available to play with. It is heavily throttled, but we will make it a bit less throttled in time. So I think, so in addition to this data integration platform to integrate all data about Parliament and all other data integration platforms, there are the previous two. There's the previous two that we support, so we had a team of 3 working constantly on that, and might tell us a bit more about that.
So our oldest triple we've got is used for, as Shami said, for internal searching of documents and procedural information that's subject tagged by a team of specialists. Later after that we have the first Parliament data platform that has over 300 million triples. That's used both internally and externally. And for the first indexing search system, that originally ingested from RSS feeds from different systems. The later data platform ingests by querying SQL databases and constructing RDF itself. So it's got a bit more control, it's got a bit more sophisticated over time. Our standard work on these is generally data fixes where we're consuming bad data from source systems or incorrectly formatted data, we need to go in and fix it. And we generally do this by queries using Workbench or by PowerShell using the Sesame endpoints.
So there's a lot of stuff and developing and maintaining these systems over the years. We've learned quite a lot. So that drove a lot of the decisions we were making on this platform. For example, investment in accessibility, I would put it. So we make the Sparkle endpoint accessible. We make all the data that the website is driven by public. Anyone looking at beta.parliament.uk and looking at the source will find alternate links to content negotiated RDF data that drives those pages. That ontology that Chris was showing, we take that and we convert that into object-oriented classes in C# that we use then to expose an OData endpoint. OData is one standard that is not the W3C style, but it does integrate into Excel. So that's really cool. People can open Parliament data in Excel. And another thing we learned from previous platform attempts is that we should invest in performance. So with this one, we've been working on this for 2 years, and from the very beginning, we were thinking cluster, and we were thinking about proper cloud deployment and proper assurance of performance. So Matthias has done a bit of work on that.
Hello, so my name is Mathieu. I've been working. I'm going to talk to you about 3 things I've done in the past year. So I tweeted Cognitive, please discuss in the open anything you want with me. So about a year ago I did some performance testing of GraphDB. We used real traffic for that exercise. So we have looked at our analytics and extracted 1,000 queries from traffic. And I have set up a different configuration of clusters to see how it would cope with 100 virtual users. And what I found out is, here you can see in blue the price it costs. It's based on a virtual machine deployed in Azure. In orange is the number of requests per second I could reach, and in gray the average response time. So with a cluster of 4 P3 V2 machines P3v2 is 4 cores, 7 gigabit of RAM, and 50 gig of storage. No, sorry, it's the smallest one. So P3v2 is 4 faster cores and 14 gigabit of RAM. So that will cost you about like £2,500, and it would run like 186 requests per second, like coping with 100 virtual users. The performance is fairly well correlated with the price we put in virtual machines. So with a cluster that's fairly cheaper, we would achieve 76 requests per second, which is not necessarily bad, especially considering the range of requests we threw at it. So here what you see is the 41 different templates of what we call fixed queries. So it is Sparkle queries that are parameterized, so they're not always running the same. They're not querying for the same entities, but they're querying for the same type of objects. And some of those, as you can see, in blue is response bytes. So the ones on the right on the screen, on your left, are like 10 megabytes of data thrown back as a client. So you would expect long response time, like this one, 10 megabytes took on average 45 seconds to reply. Considering that we were throwing like constant traffic with 100 virtual users, it's not very bad. And if you look at the lower half, which is still reasonable amount of data transferred, like 140 kilobytes for the largest one, replying in like 0.8 seconds, and most of them reply in much less.
That's resource thing, that's a describe.
That's, sorry?
Yeah, that high one on the left is a describe.
The high one on the left? Yeah, it is a describe. So the describe is probably a bit higher because we retrieve one ONS. I don't have much time, but anyway, if you're interested in reading this, I wrote at great length about the entire process. The takeaway from this is that without cache, we perform pretty well. On average, 270 milliseconds, 186 requests per second, and with cache, we cut that to 40 milliseconds of response time. So, I mean, yeah, all the naysayer of a graph is not ready for production can come to us for, how to say, infrastructure advice. So if you care to Google performance testing graph database, you should be able to find it. It's the first non-sponsored link. So, second thing, I've also worked on translating our thesaurus into scores. So, for that exercise, we exported all of the data we had, and we wrote XSL transformation to extract all the concepts into SCSI vocabulary. I think, I don't know, it's interesting to see that with very basic, simple, old school, long tested technologies, you can migrate from relatively unstructured data and non-semantic at least to nice and semantic graph. I'm not going to talk a lot more about that. If you want more detail, please talk to me. The last thing I wanted to mention is that 2 days ago we finally released with kind permission from Ontotext an image, a Docker container with our graph running inside it. So that's an announcement of the event on Twitter with a bit of details. Let me talk to you about the Docker file. It is available on GitHub, as is all of the code that we release. So you can look at github.com UK Parliament. We publish everything there. So I stripped away a bit of the bytes. So I managed to make the Docker image running from Linux Alpine. You just need to install bash for GraphDB to run basically out of the box in that. And I just download the latest copy of our data from an endpoint that we opened to the public recently. So it's api.parliament.uk/download, and there you will find all of our backups, and you can just download the data. So it's for people to be able to run it on their own. The good thing is that it enables us to completely automate the updating of a container. So basically we have a scheduled task every day. We run the build of the image. It downloads the latest graph, and it uses load RDF to put everything inside. Right now we have 12 million statements, and it takes 5 minutes to run in the cloud, and the image is 490 meg. It's not optimal, but it's a good start for letting people use, our graph. And then basically, if you're just a user, you can just type docker run, map the port, and say UK Parliament/GraphDB latest, and you will get an instance of GraphDB with our graph and the 12 million statement locally on your machine. Yeah, that's it, basically. Thank you.
So, yeah, sorry, I'm gonna say a few more words. One thing that's very interesting regarding the performance testing, I think this style of performance testing is very good. So we've taken actual usage data, a query payload running our current website, and used that as the workload for the performance testing, and I'm very satisfied with that. And I also wanted to try the BSBM, so we have some standard measure, and probably due to our own shortcomings, but perhaps not, I found it utterly impossible. So the BSBM does not want to run in a 2018 cloud-hosted cluster. I just found it impossible. We can easily make it work with one graph database running on one machine, but we weren't able to do it. I mean things like it submits all its Sparkle queries over GET, and some of those are pretty long. If you know the query mixes, they are long. They are above the URL limit size of 5 different layers of cloud hosting. So I just, after 3 months of one developer, I gave up. We'll try more, and maybe some fresher benchmarks will be good. So what I find interesting again is, just after we opened our public Sparkle endpoint, and I said, timeout is limited to 5 seconds, so don't run any select stars on us yet, please. And you can do 10 calls per second per IP. And I got responses on Twitter saying, seriously, in 2018 you should be a bit more permissive than that. And I actually have the performance data to back that, but we are conservative. So one of the suggestions was, how about make your data available as a container? So a week later, we did that. And give us all your data is some of the more frequently recurring user requests. So api.parliament/download, I'm happy to apply. So I think this is important. We invest in standard support, so W3C, content negotiation. We invest in performance when we invest in accessibility. So give it to them as Sparker for those weird people who want it. Give it to them as HTML via the website for the people. Invest in the modeling, so it's not just, oh yeah, as you put it, not truly graph data. We try to make it truly graph data and then serialize it into lists on a website. But also give it to them as OData for the crowd that enjoys that standard. Give it to them as JSON-LD and give it to them as a container. That's it.